Precision Time Protocol, or PTP, plays a critical role in Open RAN deployments by ensuring precise time is distributed throughout the network. Today, I'm going to tell you about precision timing products from Protempus and the role that they play in Open RAN scenarios. The Open RAN network offers benefits that are transforming the industry. One important benefit is that network performance and reliability can be improved. This last point is where Protempus's products operate within the Open RAN architecture, providing very accurate time and sync that can be distributed throughout the network. The Open RAN network requires PTP time distribution across the network with the goal of both time and phase sync amongst the disaggregated key elements of the system. These elements are the radio unit, the RU, the distributed unit, DU, or the centralized unit, the CU. Delayed sync amongst these elements will result in lower throughput, poor success rates, unreliable service and interference, and delivery failures and potential malfunction. In general, a PTP Grandmaster plays a critical role in the network performance by syncing all of these network devices with a common time reference, thereby minimizing the interference and optimizing the network performance. The PTP Grandmaster uses a GNSS receiver as its time source and PTP to distribute that time across the network. The Open RAN standard shows 4 configurations in the synchronization plane. The first is C1. This is a point-to-point direct connection between the DU and the RU, where the DU is acting as the network controller of the radio clients. The DU derives its time signal from an onboard GNSS receiver or through an external Grandmaster input. The second is C2. This is similar to C1 with the addition of PTP-enabled switches in between the RU and the DU to allow for time distribution across the front haul. The third is C3. In this setup, network time distribution occurs from the primary reference time clock or the telecom Grandmaster to both the DU and the RU. One or more PTP-enabled switches are allowed in the front haul network to support this network time distribution. The fourth configuration, C4, is where a local GNSS receiver provides a timing directly to the RU, independent of the rest of the elements in the front haul network. Keeping the Open RAN devices in sync is the key to optimizing network performance and stability while minimizing interference and potential malfunction. In summary, a PTP Grandmaster and PTP-enabled devices improves network efficiencies by providing accurate synchronization to network elements, thereby minimizing interference and preventing any potential malfunction. Protempus designs and manufactures these GNSS receivers and PTP Grandmasters that are vital components of any Open RAN system.